Good morning, students. This is some practice with the normal distribution. So this is all chapter 7 stuff, and you can review your notes from the end of chapter 7 to refresh yourself. We're going to use this a lot going forward. More about that to come, but for now, let's just practice with the normal distribution. Okay, so this is your worksheet, and I'm going to call this answer key. Okay, because it is your problems worked out here, at least some of them. So, number one, we'll work this one out completely. Using this curve below, this is the standard normal density. So, the red curve here is the density of a normal distribution with mean 0 and standard deviation 1. All right, and I've got the blue region shaded, and it's everything from the left all the way up to 1.88 on the right. It's everything under the curve, above the x-axis, and to the right of 1.88. So this is the probability that my standard normal variable z is less than 1.88. So if it says my answer is, can I highlight that? I cannot. Oh well, I'll circle it with the red dot here for a moment. Our shaded region is 9.699 or 0.699. That is our answer. So probability that z is less than 1.88 is 9.699. There. Okay, probability that z is greater than would be everything but that region. So if we zoom way in and shade just this region here, that would be the probability in part B. That's pretty poor shading. So just shade it with your mind. Use your imagination there. So this is the exact complementary event. So my probability here would be the entire region you'd get if you shaded everywhere underneath this curve, from negative infinity on the left all the way up to positive infinity. That would be 1, minus the blue shaded region, which is the probability of being less than 1.88. So 1 minus 0.9699, which is 0.0311. So your answer for part B is just 3.11% or 0.0311. Okay, well, what's not marked anywhere on this axis is negative 1.88, but if I had to guess, it would be right about here. Let's put a little dot there. Right there. Maybe make a perfect little line here. Boop. Okay, so everything to the left of negative 1.88, you might feel kind of cheated right now. That's not really on the diagram. So how on earth can we just guess this? Maybe you guys are way ahead of me. But in case it's been a long day already and you're not quite sure what I'm talking about, what I'm getting at here is that the normal distribution is completely symmetric. So that means every picture you see to the right of the y-axis is completely mirrored to the left of the y-axis and vice versa. So I just found the probability of this tail region right here, which I shaded and then erased, but I'll kind of reshade it. And I make it look like it stops here right about 3. It keeps going on forever to the right, just very narrow. Okay, that tail region is exactly symmetrical to the one that I'm interested in. So actually this answer is the same as part B, symmetry. Okay, so that knocks out number one. Number two, very similar. So have at it. Let me know if you have questions, but number one and two were solved in a very similar way. Okay, number three, use a standard normal table. So you guys are in the classroom right now. So if you look on the side of the classroom, you'll find stacked along the wall a bunch of stats books. You can just grab one and you can find the normal table in there. Or if you really like seeing things electronically, you can go down here. I see this is not being screencastified. Okay. Well, take my word for it, but on Web Assign, you can find your ebook. Go to the ebook, go to the tables. Table 2 is the one you're interested in. So you can use table 2 on the ebook. Or maybe you saved your handout from last semester. That'd be awesome. Okay, so how do you use the standard normal table? I'll do, which one should I do? I'll do the first one. I think that's the hardest. Okay, part A, probability that Z is between negative 2.01 and negative 1.87. So the table is good for looking up probabilities that Z is less than. So look up probability that Z is less than the bigger of the two, negative 1.87. That's less than, and then that's a negative. And then subtract from it the probability that Z is less than smaller. So if I look this up in the table, I look up negative 2.01, and I get 0.0222. And I look up negative 1.87, and I get 0.0307. Let's double check. Yep, 0307. So this will be 0.0307 and minus 0.0222. So that is equal to 0.0085. All right, so that would be your final answer right here. That bold. Okay, there you go. Part B, much easier. You just look up 0.17. That should be good. Okay, these, part number 4, I'll do part A. These, you look these up backwards. So for A, you're finding the value C. So I'll go over here. C equals. So we just look for this probability in the table as close as you can get it. So 0.1151 does show up in the table. So we find it, and it's right there. If you look in the negative 1.2 row, in the 0.00 column, it's right there. So that corresponds to C equals negative 1, or rather 2. Oh, I had it. I'm going to just get it again. Yeah, negative 1.20. All right, and then some help on part 5. This is real data, by the way, so if you have taken the SAT or you plan to, in 2017, right before you started your freshman year, I guess. The average SAT score was 1149, and the standard deviation was 212 points. So if you took the SAT and you got better than 1149, congrats, you are better than the average 2017 high school student. Okay, so average was 1149, and then suppose that this is a normal distribution. So this is not standard normal. Standard normal has mu equals 0, not 1149. So this is shifted to the right quite a bit. And standard normal has standard deviation 1, not 212. So this is stretched out quite a bit. How do we find probabilities? Like here, what's the probability of being greater than 1200? All right, so what we want to do is we want to use z-scores. Okay, so instead of using 1200, okay, I'm going to convert. So convert 1200 to a corresponding standard normal. So we're going to take 1200, subtract off the mean. So z is going to be, I'll use parentheses because this is not a very good math typewriter right now. So it's going to be 1200 minus the mean, which is, yep, 1149. And then divide by the standard deviation, which is 212. Okay, so we get 1200 minus 1149, and then divide that by 212, and we get about 0.2405. I'm going to round to 0.24. Okay, so that looks like you're saying, hey, okay, 0.24, that looks like a number between 0 and 1. I bet that's our probability. No, that's only our z-score. So this is just what we use to find probability. So the probability that my SAT score, we'll say SAT score is greater than 1200, is going to be the same as the probability that my z-score is greater than 0.24. So I go to my table and I look up 0.24, and then I do 1 minus that. Wouldn't you know, I just got logged out of WebAssign, so we log back in, twiddle our thumbs. There we go. So 0.242021, 2, 3, 4. It's 5948. So we'll do 1 minus 5948. We get 4D52. Okay, let's bold that. So the probability of getting a 1200 or better was about 40%, 40.52%. All right, well, have fun with the rest of this assignment. This is going to be due at the end of the day, so you can turn it into me on WebAssign and get as far as you can with it. Work in groups, fine with me. There's going to be a quick quiz over this in class tomorrow. So it's going to look exactly like this. I'm going to change these numbers instead of 1.88. Maybe it's going to be negative 0.15. I don't know. I'll change it. I'll change each one of these and give it to you again tomorrow as a quiz. So do your best to understand it today. And then, yeah, quiz time tomorrow. It should be an easy 15-point quiz.